talk about piecewise functions. Piecewise functions. And they are very well named because they're made up of pieces of other functions. Let's look at this one. It looks to me as though that could be a quadratic part of a function, right? Like half of a parabola. And then it suddenly changes and becomes linear. In fact, this is a special kind of linear function that's called a constant function. So I'm making one function out of two pieces. This is how it might look when we graph it. This is how this would look if we wanted to write it out in function notation. So I'm going to call this whole function f of x. And what I do is I break it down into its pieces. This piecewise function has two pieces. So I have two different equations. And as you see, I have to write the domain, which tells me when I'm on each piece. So this basically says, for all of the x values from 0 to 3, from all the x values from 0 to 3, I'm on this equation. So when x is 0, I find my y by plugging 0 into this equation. When x is 1, I find my y by plugging in 1 for x into this equation. When x is 2.5, I'm still on this piece. When x is 3, I'm still on this piece. Right? Let's try it. When x is 3, 2 times 3 squared, well, that's 18. When x is 3, my y value is 18. But then, when x is 3, I suddenly move, when x is a little bigger than 3, to my second piece. Because the second piece is from all x's between 3 and 8 inclusive. So when x is 3.0001, I'm on this piece. Boom. When x is 5.7, I'm on this piece. All the way up to when x is 8. And that's when the function ends. Now, I can do everything I do with other functions with this function. I can ask for the domain of this function. All right, well, what's the domain of this whole function? Oh, well, it's all the x values, so I'm going from 0 all the way up to 8. Looks like 0 is not inclusive, but 8 is inclusive. What's the range of this function? Well, let's see, my smallest y value is 0. My biggest y value is 18. So, from 0 to 18 inclusive. Okay? I could evaluate this function. So, for example, if I wanted to evaluate f of 4, I'd say, okay, let's see, do I go to this piece? No, because my x is 4. I have to go to this piece. All right, so when x is 4, my y is 18. Okay, that makes sense. What if I wanted to evaluate f of 2? Let's see, when x is 2, I go to this piece because 2 is between 0 and 3. So I plug in 2 for my x, 2 times 2 squared, which would be 8. So f of 2 would be 8. So I can evaluate piecewise functions, I can find the domain and the range. I can do everything I do with a normal function with a piecewise function.
I'm not too woman, I'm not too man. I am something that you never understand.
Let's look at another piecewise function. This function is made up of 3 pieces. Okay? I'm just saying y equals, I guess I should really write that in the middle. It looks a little funny there. Y equals. So my first piece is a line, x plus 3, and that is for all x's less than 2. So let's graph this. Well, we know how to graph a line. That is my y-intercept of 3, 1, 2, 3. It has a slope of 1, up 1 over 1, up 1 over 1. I can go down 1 over 1, down 1 over 1. But it's only up to where x equals 2. So when x is 2, this is where I end, right there. But it's for all x's less than 2. So there's my first piece. So now let's graph my second piece. My second piece is a constant function, right? It's a horizontal line. So my y value is always going to equal 5 for all the x values between 2 and 8. Okay, here we go. When x is 2, 1, 2, 3, 4. Oh, well, this is handy. It touches the piece that just ended. So I'm starting from the piece I ended, and I'm going to go up to 8, boink, and draw my horizontal line at a y value of 5. So there's my y equals 5. This was my y equals x plus 3 piece, y equals 5 piece. Okay, I'm on a roll. Let's graph my third piece. 2x minus 6. Okay, so this is also a linear function. But gosh, y-intercept is down here, but I'm not even going to graph the line over here. This line, this piece starts only when x is 8. So this is a little tricky. But you know what you can always do? You can always just plug in some x, y values and plot some points. So I'm starting at 8. So when x is 8, let's see what output, what y value I get. 2 times 8 is 16, minus 6 is 10. All right, so 8, 10 is where this piece begins. So when x is 8, y is up. Okay, I'm not starting where I ended before. So let's see, that's going to be a closed-in circle because that's inclusive. This guy right here has to be an open circle. Do you see that? Okay, I could plug in more points if I wanted to. So let's plug in a 9. 2 times 9 minus 6. That's 18 minus 6, which is 12. 9, 12. 9, 12. And I'm going to draw an arrow to show that that continues. Of course, another way I could have done that is once I know one point, I know the slope of this piece is 2, I could have just gone up 2 over 1, up 2 over 1. Okay, so now I have my 3 pieces. Now I'm kind of writing the separate equations so you can see that. But really, this all is one function. This is considered one function. And I can name this function, let's name it h of x, shall we, just for fun? So this whole function we'll call h of x. And it's made up of these 3 pieces. So I'm going to erase the little equations now. So just as we did before, we can evaluate, we can find the domain and the range. Let's go ahead and do that. What is the domain of h of x? Well, domain, remember, is all the x, the set of all possible x values. I'm starting from the left. It looks like every x is involved, every x, every x, every x. Okay, that 8 is included up there. Hey, I'm thinking my domain is all real numbers. Okay? How about the range of h of x? That's the set of all possible y values. So let's see, if I'm starting swooping down from up, all right, this guy is going down, down, down. All these y values are going to be part of this piece. So far, so good. All these y values are good, but then, oh my gosh, look, there's this whole region of y's that don't get to participate in this function h of x. So let's see. It looks as though my range goes from negative infinity up to and including a y value of 5. And then my range goes from a y value of 10 all the way up to infinity. That would be your range. Is this making sense? Let's do some evaluating just for fun. Let's evaluate h of 7. Okay, so this, remember, is your x. So you have to find the correct piece. I'm not on this piece when x is 7, right? When x is 7, I'm on this piece, right? 7's between 2 and 8. So when x is 7, h of 7 equals 5. Let's try h of -1. Okay, when x is -1, what piece am I on? Oh, I'm on this first piece. I'm on this first piece. So it's going to be -1 plus 3, which is 2. Okay? If I wanted to find h of 100, well, let's see. 100's way out here, right? I'd be on this piece. So I'd have to plug 100 into this third piece. Piecewise functions can be a little weird at first, but once you get the hang of it, they're kind of fun.